To my channel, and today we're gonna cover physics gravity. So we're gonna cover questions that are similar to the previous video I uploaded about acceleration and velocity questions, but this time we're gonna use gravity as acceleration. Okay, so it's basically the exact same as we had in the previous video I uploaded, but the only thing I want to cover this time is, before we start, is first, we're using theoretical physics, so there's no air friction. We don't really care about air friction, wind, and other earth factors we have on the Earth. Okay, and the second one is that we're gonna use acceleration due to gravity. We're gonna use 9.8 meters per second square, and we're not gonna use that you might see it somewhere as 9.81 or 9.8099 or even 10 meters per second for junior shares. Okay, so we're gonna cover it and we're gonna use it as 9.8 meters per second. So let's start with the meat of the problem. So basically it says a brick falls from the top of a 5-meter high building. Calculate the velocity which the brick reaches the ground. How long did it take to reach the ground? Okay, so we have two questions. We have this question here and this question here. So let's start with it, just writing the data we know. So we have that a brick falls from the top of a 5-meter high building. So if I have a brick and I let it go for 5 meters down to the ground, right? That is 5 meters. The distance is going to travel from the start until the beginning, until the end, is going to be 5 meters. Okay, so the distance is equal to 5 meters. So let's write it down. Distance is equal to 5 meters. We know that the acceleration due to gravity is going to be 9.8 meters per second square, as we said before, and we know that the initial velocity is going to be 0, as where you're holding a stone or a brick from your window. Just the moment before you let it go, it's going to be 0. It's not going to be moving because you're holding it. Okay, so it's going to be 0 meters per second. Obviously your hand could be like vibrating a little bit, it can be shaking a little bit, but as we said before, this is theoretical physics. So then the question asks us, calculate the velocity which the brick reaches the ground. So basically velocity, final velocity is going to be equal to question mark. So this is going to be part of the first problem, and this is going to be part of our second question. Okay, so what formula can we use that includes those 4 values? So well, we need V. Let's put it green. Do we know V? Yes, we do. Well, we don't. We need it. Do we have U? Yes, we do. Do we have A? Yes, we do. And do we have S? Yes, we do. So we can use that formula there. Okay, so we have V squared is equal to U squared plus 2AS. So V squared is going to be our variable. 0 is 0. 0 squared is 0. 2, gravity is 9.8, and this is going to be 5. So we know that V squared is equal to be 98. Now, how do we get rid of the square here? Well, we can just do the square into everything. Okay, so you can do one part of the equation, you can do to the other one, and this cancels out, so we have the V is equal to root square 98. You either have the option of leaving it like this, or you can leave this as a root square, or you can just do the actual value, which is going to be V is equal to 9.9. Okay, but we're gonna leave it as this. Why would you leave it as a root square? Well, we can leave it as a root square because it is more accurate, because the root square of 9.98 might have infinite values, after the comma or the dot. So let's say it might have like infinite is a fraction, or it might be a decimal point, and after the decimal point it might have infinite numbers, and we can't really write infinite numbers on a piece of paper. Okay, so if you leave it as a root square, it's going to be more accurate. Okay, so you might want to leave it like this. Okay, 98. I am going to leave it like this, but you can do whatever you want. So we have part of the first question done. Second part, how long does it take to reach the ground? Okay, so basically time it takes to reach the ground. Time is going to be our variable now. So what formula can we use? Well, we can use the first one again. So v is equal to u plus at. So v, we know it's root square of 98. U is equal to 0. A is going to be 9.8. And t is going to be our variable, okay? So we can call it x, t, whatever you want. So then we got that t is equal to root square of 98 divided by 9.8. So we're going to get that t is equal to 1.01 seconds, okay? So now we have this question done. So let's do this question. A stone is dropped from a window. It takes this stone 1.5 seconds to reach the ground. How high above the ground is the window? So what do we know? Well, we know that the time is going to take to hit the ground is going to be 1.5 seconds. We also know that the acceleration due to gravity is 9.8 meters per second square, as I said at the start of the video. What else do we know? Well, we know that the initial velocity is going to be equal to 0 meters per second, and we also know that, well, we don't know the distance, but it's asking us for the distance, okay? How high above, so that's distance. So we're going to call it question mark. So what formula should we use? Well, we can use the first or the second one. So let's use the second one as we use the first one on top, okay, in the first question. So s is equal to ut plus a half at squared. So s is going to be a variable, so we're going to leave it as that. U is going to be 0, so 0 multiplied by a number is 0, so I'll leave it like that. A half of 9.8 multiplied by t squared. You can put this in brackets. But wait a minute, we know times is going to be 1.5 squared. Okay, so what do we get? Okay, well, we know that s is equal to 4.5 multiplied by 1.5 square, and if I get the calculator, we will get that 4.5 multiplied by 1.5 square is equal to, s is equal to 10.125 meters. So basically roughly 10 meters, a bit more than 10 meters, okay? So that's going to be the answer for our problem, and that's going to be the end of it, okay? So I hope this video helped you, and thanks for watching.